Hello, welcome to all of you. Now we discuss about the paper CC-9 Group C Multivariate Calculus 2 2022 Mathematics Honors Semester 4 Calcutta University B.Sc Honors in Mathematics. Question paper 2022 Group C. Question 7. Using differentiation under the sign of integration, find the value of integration 0 to infinity e to the power minus a square x square cos square bx dx. Let f x b equal to e to the power minus a square x square cos square bx, x greater than equal to 0. B is a parameter. First we check the following 4 conditions. Number 1, f x b is a continuous function of x and b. Number 2, let phi b equal to integration 0 to infinity e to the power minus a square x square cos square bx dx. And since modulus of e to the power minus a square x square cos square bx is less than equal to e to the power minus a square x square for all x greater than equal to 0, because this cos square bx is less than equal to 1, and integration 0 to infinity e to the power minus a square x square dx is convergent, then by Wester's M test, phi b is uniformly convergent for all b. This is the Wester's M test if fx be a bounded and integrable on the closed interval a b greater than a, and mod of fx b is less than equal to mx for all x greater than equal to a, and if integration a to infinity mx dx is convergent, then integration a to infinity fx b dx converges uniformly for all b. Number 3, now del b of f is equal to minus e to the power minus square x square into x 2 cos bx into sin bx equal to minus x e to the power minus square x square sin twice bx. Clearly del b of f is continuous for all x greater than equal to 0 and for all b. Number 4, now modulus of del bf equal to modulus of minus x e to the power minus a square x square sin twice bx less than equal to x e to the power minus square x square for all x greater than equal to 0. And since limit b tends to infinity 0 to b integration x e to the power minus square x square dx equal to limit b tends to infinity 1 by 2 a square integration 0 to a square b square e to the power minus z dz, and putting z equal to a square x square, so dz equal to a square into 2x dx, so changing the variable x to z and limit also, we get this. After integrating we get 1 by 2a square limit b tends to infinity bracket 1 minus e to the power minus a square b square. When b tends to infinity, so this tends to 0, so this we get 1 by 2a square. So integration 0 to infinity x e to the power minus square x square dx is convergent. And so by Wester's M test, integration 0 to infinity del b f dx is uniformly convergent for all b. Hence the conditions of differentiation under the sign of integration are satisfied, and then by theorem of for differentiation under the integral sign, we get phi dash b, and this phi dash b equal to integration this integration del b f dx, this is the b, not y, this is b. Del b phi b, phi dash means del b phi b, this equal to this. So integration limit a tends to infinity, integration a to capital A x e to the power minus a square x square sine twice bx dx. So we get 1 by 2 square limit a tends to infinity, integration 0 to a into bracket minus 2 square x e to the power minus a square x square sine twice bx dx. By parts integration we get on this is the sine is the second function and this is the first function. So we get this limit 0 to a, so obviously this 0, and for this twice b integration to the power minus a square x square cos 2 bx dx. Now cos 2 bx is equal to 2 cos square bx minus 1, so 2 to cancel, so b by s minus b by s square 0 to infinity to the power minus a square x square into bracket 2 cos square bx minus 1. Now this minus 2b by s square and this integration 0 to infinity to the power minus a square x square cos square bx and dx is equal to phi b, is equal to phi b. This is the phi b, this is the phi b number 1. So we can write this phi b, and this minus into minus plus b by s square integration 0 to infinity to the power minus a square x square dx, this equals to root pi by 2a, and because this integration 0 to infinity to the power minus a square x square dx, this equal to limit it tends to infinity, this putting z equal to a square x square, so we get this gamma function gamma half 1 by 2a gamma half root pi 2a, so we get this. So phi dash b plus twice b by a square phi b is equal to root pi by 2a cube into b, and the corresponding homogeneous equation we want to solve for phi b, so right hand side this equal to 0, corresponding homogeneous equation. So phi dash b by phi b equal to minus 2b by a square. Integrating we get log phi b equal to minus b square by 2 a square, this plus log c is an arbitrary constant. So phi b equal to c e to the power minus b square by a square. Then c equal to phi 0 when b equal to 0, so this equal to e to the power 0 1, so phi b equal to phi 0 equal to c. Now phi 0, that means b for 0, b equal to 0, so put phi equal to phi 0 to infinity e to the power minus a square x square cos square 0x, this 1, so 0 to e to the power minus a square x square dx phi 0. So we get phi 0 is equal to this is equal to root pi by 2a, already we find this, so phi b equal to this is the phi b equal to root pi by 2a, this is putting the value of c, that is the c e to the power minus b square a square, this is the complementary function of this differential equation 2. Now find the particular integral of the differential equation 2, first order differential equation 2 is equal to particular integral equal to bracket d plus 2b by a square whole inverse root pi by twice a cube into b is, so taking common a square by twice b, and this d transport d db bracket 1 plus a square by twice b d whole inverse b, expanding this 1 plus d whole cube minus 1, this is 1 minus d plus d square minus d cube plus so on, and this is the d for with respect to d with respect to b, derivative with respect to b, so this 1, so we this 1 minus d of b equal to 1, so we get particular integral is this, so phi b equal to complementary function plus particular integral and taking common root pi by twice a. So we get this 1 by twice b bracket 1 minus a square by twice b, and this is the answer of 5b. Next question 8. Evaluate the integral double integration dx dy whole divided by bracket 1 plus x square plus y square whole square taken over the triangle with the vertices at 0, 0, 2, 0 and 1 root 3. No figure, no marks here. The x-axis, y-axis, this 0, 0, 2, 0 and this 1 root 3. And so the equation of this line OB, so this y minus y1 by x minus x1 equal to y1 minus y2 by x1 minus x2, joining these 2 points 0, 0 and 1 root 3. So we get y by x equal to root 3, so y equal to root 3x, the equation of the line OB. And the equation of the line AB is this y minus y1, this 0, x minus x1, this 2, y1 minus y2, x1 minus x2. So with y by x minus 2 equal to minus root 3, so y equal to minus root 3 into bracket x minus 2 is the equation of this line AB, and this is the region double integration over the region E. And the equation of OB is this, and equation of the line AB is this. The region of integration is E as bounded by this triangle OAB. Now we want to change this xy Cartesian coordinates to polar coordinates r theta. For this, choose x equal to r cos theta, y equal to r sin theta, and the Jacobian for this transformation J, this del xy by del r theta is equal to r, is positive greater than 0 when r theta not equal to 0, 0. Now change the equation 1 and 2 into polar coordinates. This equation 1, this line OB and this line AB to polar coordinates, put x equal to r cos theta, y equal to r sin theta. So we get r sin theta equal to root 3 r cos theta, tan theta equal to root 3, root 3 equal to tan pi by 3, tan 60, so theta equal to pi by 3. So the equation OB is the in polar coordinates, this line theta equal to pi by 3. And equation 2 becomes this, so we get r equal to root 3 sec of theta minus pi by 6 is the equation of the line AB. So in r theta form we get this is the polar line, initial line OA, that is the x-axis, and this is the OB, this equation theta equal to pi by 3, and this line AB, this is equal to r root 3 sec theta minus pi by 6. So r changes from 0 to root 3 sec of theta minus pi by 6, and then theta changes from theta equal to 0 the initial line to theta equal to pi by 3. So this the given integral becomes theta equal to 0 to pi by 3 and r equal to 0 to root 3 sec of theta minus pi by 6, 1 by 1 plus r square, because this 1 plus x square plus y square equal to r square whole square, and dx dy and into Jacobian mod of Jacobian j into dr d theta, that j equal to r, so r dr by 1 plus r whole square d theta. Now put 1 plus r square equal to z, so twice r dr equal to dz. So this integration r dr is dz by 2 into z square, so 1 by 2 minus 1 by 2 1 by z, that is minus 1 by 2 1 plus r square, and the limit from r equal to 0 to root 3 sec of theta minus pi by 6. So r equal to 0, putting 0 when r equal to this, we get this value minus of this when putting r equal to 0, so minus minus plus, so 1, so r equal to 0, 1 by 2 common, taking common this, so we get this. Now simplifying, we get, and using the result 6 cos theta equal to 1 plus tan square theta, so we get after simplifying this 3 sec square of theta minus pi by 6 whole divided by 4 plus 3 tan square theta into theta minus pi by 6, and put p equal to tan of theta minus pi by 6, so dp equal to 6 square theta minus pi by 6 d theta. When theta equal to 0, p equal to minus 1 by root 3. When theta equal to pi by 3, p equal to 1 by root 3. So changing the variable from theta to p, integration limit p equal to minus 1 by root 3 to 1 by root 3. So we get this. Now this is the 3 by 4 plus 3p square is the even function. So 2 into integration limit 0 to 1 by root 3, and this 4 and dividing by 3, and this, so 4 by 3, so 4 by 3 you can write 2 by root 3 whole square. So this is the, from 2 to cancel, so root 3 by 2 tan inverse root 3p by 2, and because we know this integration dx by a square plus x square equal to 1 by a tan inverse x by a plus c. So tan inverse x is p, and by a is the 2 by root 3, so root 3 by 2, so root 3 by 2 tan inverse half, and this is the answer. Next question 9. Find the value of the integral triple integration over e dx dy dz whole divided by x square plus y square plus bracket z minus 2 whole square, where e is the set of all those x y z, this order triplet x square plus y square plus z square is less than equal to 1. And this is the sphere x square plus y square plus z square equal to 1 is the sphere, unit sphere centered at origin with radius 1, and all interior points and these boundary points, this less than equal to this is the region volume of this interior and exterior interior and boundary points, this less than equal to 1. Changing this spherical polar coordinate, this x equal to r sin theta cos phi, and this is the phi, and this is the theta, and this is the x-axis, y-axis, z-axis, this is the r equal to r sin theta sin phi, z equal to r sin theta, and this in r e dash is the set of all those points r theta phi such that 0 less than equal to r less than equal to 1, 0 less than equal to theta less than equal to pi, and 0 less than equal to phi less than equal to 2 pi. And the Jacobian for this transformation, this j equal to del of del xyz by del r theta phi, this, remember this result, r square sin theta, this is greater than 0 except when r equal to 0 or theta equal to 0 or theta equal to pi, this that is when x equal to y equal to z equal to 0. That actually when r equal to 0, that means x equal to 0, y equal to 0, z equal to 0, this is the origin. And when theta equal to 0, so x equal to 0, y equal to 0, and z equal to r. So 0 0 r, actually this is the positive z axis. When theta equal to pi, this is the and 0 0, this z is minus r, that is the negative z axis. That actually this Jacobian j is positive except on this line z axis, on the point on this z axis and this z axis. Now this region e changing to e dash, and then the integration, triple integration changing from e to e dash in this spherical polar coordinates, this. So this is Jacobian r square sin theta dr d theta d phi by x square plus y square plus z minus 2 whole square equal to this equals to r square plus 4 minus 4r cos theta. So this is the phi equal to 0 to twice pi actually, and this r equal to 0 to 1 unit radius of sphere radius is 1, so r equal to 0 to 1, and theta equal to 0 to pi, So theta, when theta equal to 0, is the positive z axis. When theta equal to pi, is the negative z axis on this line. So theta equal to 0 to pi, and then move this phi equal to 0, when 0 is the x axis, on this x axis to twice pi. So this in anticlockwise sense, this rebound this x axis, this phi equal to twice pi. So this integration 4r, 4 cancel, so r square, so 4r sin theta by r square, 4r cos theta plus 4 d theta dr. Actually this is the log of r square minus 4r cos theta plus 4. If we put r square minus 4r cos theta plus 4 equal to z, then this 4r sin theta d theta equal to dz. So this log of this, limit theta equal to 0 to pi, and this dr. So when theta equal to pi and this cos theta equal to minus 1, so this r square plus 4r plus 4, that is r plus 2 whole square. And when theta equal to 0 is 1, so r square minus 4r plus 4, so this is equal to 2 minus r, because r is less than equal to 1, this sphere of unit radius, so 2 minus r is greater than 0. So we write 2 minus r whole square this. So now this d phi is integrating this 2 into pi. So this integrating, we get within bracket, choose this first function and this r is second function. So by parts integration, we get this into this into integration of r square by 2, integration of r, this r square by 2, limit r equal to 0 to 1, and this first function, so derivative of this, so 1 by 2 plus r minus plus 1 by 2r bracket r square by 2 dr. And simplifying this, 4 by 4 minus r square into r square by 2, so we get this, and this 4 minus r square minus 4 by 4 minus r square, so we get this 4 cancel 2, so 2 pi is here, so 1 minus 4 by 4 minus r square. So from this part, this r, after integrating this, get r from 0 to 1, and this 4 into 2, so 8 pi integration this dr by 4 minus r square. Now integration dx by a square minus a square equal to 1 by 2a log to the base e mod of a plus x by a minus x. So you get log of 2 plus r by 2 minus r, limit integration 0 to 1. So after simplifying, we get this 2 pi minus 3 pi by 2 log 3 to the base e, and this equal to pi common into bracket 2 minus 3 by 2 log 3 to the base e, and this is the answer. Next question 10. Define conservative vector field F vector and express its relation with the scalar potential phi xyz. Write down the Gauss's divergence theorem in case of an irrotational vector over the hemisphere centered at origin. Conservative vector field, let a vector is a function of xyz be a vector function defined on a region E, a subset of R3, the Euclidean space, and also let F vector is continuous in E, then F vector is said to be a conservative vector field if the line integral integration over C, F vector dot dr vector is independent of the path C lying in E. And this relation with the scalar potential phi, very important relation, this theorem, F vector, if F vector is conservative, then F vector equal to grad of phi, where phi is single valued scalar function having the continuous first order partial derivatives in E. If F vector conservative, then this result holds, F vector equal to grad phi, and if F equal to grad phi holds, then F vector is conservative. So first we choose f equal to grad phi in E, and phi is a single valued function in E, and A and B be to any two points in the region E, and C can be any path from the joining the points A and B. Then integration for C, f vector dot dr vector equal to grad phi dot dr over C integration. Now grad phi is the del phi del x I cap, del phi del y j cap, del phi del z k cap dot dx I cap, dy j cap, dz k cap. So we get this, and this is equal to d phi, integration over d phi, and this is the integrating with phi a to b, that is phi b minus phi a. And this shows that integration over C, f vector or dr vector depends on the path points A and B only, not on the path joining them. Hence, the vector field F is conservative by the definition of conservative field. Conversely, let this integration over C, line integration, f vector dr vector is independent of the path C, joining the points A, this fixed point x0, y0, z0, and P, x, y, z in E, a fixed point P, an arbitrary point on C. Let phi is a function of x, y, z equal to integration a to p f vector dot dr vector. This is equal to integration over x0, y0, z0 to x, y, z f vector dot dds of r vector ds, arc length ds. And differentiating both sides with respect to s, we get dds of phi, this is equal to f vector dot ds r vector. But dds of phi equal to del x phi dds of x plus del y phi dds of y plus del z phi dds of z, and so this we can write this this into this. So this is equal to grad of phi dot dds of r vector. Hence from 1 we write this equal to grad phi dot dds of r vector equal to vector dot dds of r vector. So grad phi minus f vector dot and dds of r vector equal to 0. This equation 2 is true irrespective of the path joining the points A and B, and that is the irrespective of the direction of dds of r vector, which is a tangent vector to the path C. Hence grad phi minus f vector equal to 0 vector, that is f vector equal to grad phi. Proved. Next question, third part is the write down the Gauss divergence theorem in case of an irrotational vector over the hemisphere centered at origin. And this is the hemisphere centered at origin. This is the hemisphere units. We choose this x square plus y square plus z square less than equal to 1. This is the unit sphere centered at origin. This when choose z greater than equal to 0. So z greater than equal to 0. So this is the indicates that's this hemisphere, not sphere. Let f vector be an irrotational vector. The hemisphere D is bounded by the surface S, consisting of two smooth surfaces S1 and S2. And see the figures. This is the S1 surface, curved surface of the sphere, and this A2 is the circular plate on the xy plane, and this joining this combining these two surfaces S1 and S2. And now the Gauss divergence theorem gives the triple integration over D, and D is the region in the hemisphere, and divergence f vector dv. This is equal to double integration surface integration this S1 f vector dot n1 vector ds plus double integration surface integration S2 on S2 f vector dot n2 cap ds. This n1 vector n1 cap, this is the unit vector, outward unit normal on the curved surface S1, and this curved surface is let g equal to x square plus y square plus z square minus 1 equal to 0. This hemisphere, surface of the hemisphere, this curved surface. Then n1 cap equal to grad g by modulus of grad g, and this equal to grad g equal to this. So we get x cap, xi cap plus yj cap. and the x square plus y square z square equal to 1. So we get this. And S2 is the plane circular plate in the xy plane, and this is the plane circular plate. And so N2 cap is the outward drawn unit normal on S2. So obviously N2 cap equal to minus k cap, because is the is along N2 cap is along the negative direction of the z axis, negative z axis in the direction of the z axis. So, and this S2 surface is given by x square plus y square minus 1 comma z equal to 0, the circular plate. X square plus y square equal to 1, actually this is the cylinder, so cut by this plane z equal to 0, so this is the circular plate in the xy plane. Clearly N2 cap equal to minus k cap, outward unit normal of S2. So Gauss divergence theorem for hemisphere, actually this is the Gauss divergence for hemisphere. This is the surface S1 and surface S2, combining these two surface integrals here, N1 cap, N2 cap. Here. Next question. Question 11. Find this closed integration on C x dy plus y dx bounded by the closed contour of asteroid with x equal to a cos cube t and y equal to a sin cube t. Now Green's theorem in plane R be a closed region of the xy plane bounded by a simple closed regular curve gamma, and if p and q are continuous functions of x and y having continuous first order partial derivatives in R, then closed line integration over gamma, this p dx plus q dy equal to this surface integration over R. This R is bounded by this curve gamma, this del x of q minus del y of p into dx dy in the xy plane, where the line integral is taken in the positive sense, that is anticlockwise sense here. Here closed integration over C x dy y dx, obviously this dx, so this p, so here dx is y, so capital P equal to y, and dy is q, with the dy is q, so q equal to x. Then del y p equal to 1 and del x of q equal to 1. From this 1, if we put del x equal to 1, del y equal to 1, so 1 minus 1 0, so we get closed integration over C x dy plus y dx, actually this equal to 0, this is the answer. So that the line integral around any closed path, in particular the asteroid, actually parametric form given in the question, so x to the power 2 by 3 plus y to the power 2 by 3 equal to e to the power 2 by 3, parametric form is this x equal to a cos cube t, y equal to a sin cube t equal to 0. Note that a necessary and sufficient condition about the closed integration over gamma p dx plus q dy equal to 0 around any closed path gamma on R is that this condition del y p identical equal to del x q on R. So this closed integration is 0 when this del y p identical equal to del x q on R. If these results holds, integration 0, then this result holds, and if these results holds, and then this integration, closed integration equal to 0. Next question 12. Find the surface area of the region common to the intersecting cylinder x square plus y square equal to a square and x square plus z square equal to a square. Actually this is the two cylinder, this the shaded portion, and this the axis is y, so this cylinder x square plus z square equal to a square, and this is the horizontal cylinder, and this is the vertical cylinder, axis is z axis. This equation is this x square plus y square equal to a square. So bounded by this region common to the intersecting cylinders. So this is the figure, and this portion is this portion, from this portion is shaded. So this is the x square plus z square equal to a square, and in here this portion is this, and from this side we get this, and this side this. Actually we get this is the 4 sides here. Now x square plus z square equal to a square gives z equal to plus minus root over a square minus x square. Actually plus sign for this portion means actually this portion of this circular cylinder, this portion, and this lower portion is this portion z equal to minus of this del x z whole square. Actually this equal to x square by a square minus x square, and this, and del y z square equal to 0 because z is independent of y here. And taking the projection of this area on the xy plane, taking the projection of this area on the xy plane, and we get this equal to d, or integration, surface integration over d whole root over del x z whole square plus del y z whole square plus 1 dA. d is the dx dy. So putting all this and simplifying, we get integration over d a by whole root over a square plus x square dA. Actually dA is the dx dy on the xy plane. Now this double integration, limit of this double integration, actually this portion, this is the circular portion on the xy plane. So this ring is this x square plus y square equal to a square. This ring is this x square plus y square. This is the ring. This is the ring x square vertical cylinder, for this vertical cylinder, and this is the ring, and the projection of this ring on this xy plane. So this is the ring is this x square plus y square equal to a square, and this is the by this bounded by area bounded by this vertical cylinder, this. So this portion, this shaded portion of this cylinder x square plus z square equal to a square. So this is the portion. Actually this portion is the if we look this cylinder from the vertically below, so we get this portion is actually x square plus z square equal to a square. So this portion is the this shaded portion is the x square plus z square equal to a square on the xy plane. So in the xy plane, that is z equal to 0. So z equal to 0, put z equal to 0 here for this inner portion this. So x equal to plus minus a, and for this portion, for this this ring, this y, range of y, this a square minus x square whole root over plus minus of this. So minus y equal to this, and from x equal to plus a to minus a to plus a. So for this portion, for this vertical cylinder, this outer circle, and this inner portion from coming from the horizontal cylinder x square plus z square equal to a square, and this projection on the xy plane. So limit y limit is tends equals to minus root over x square minus x square to root over x square minus x square this, and dy dx. X is limit x equal to minus a to a. So we get this integration with respect to dy. So this is the function of x, so only we get y, and putting this limit we get this. So cancel this. So 2a. So 2a into dx. So we get x minus a to a. So actually a plus 2a, twice a, is 4a square. And so this 4a square is the for this portion only. So we get another 4 parts. So we get 4 into 4a square. Actually 16a square is the required surface area. This is the answer. Actually this portion is the for this portion is this, for this portion we get so similarly we can get other portions, 4 portions. So we get the required surface area 4 into this 4a square equal to 16a square. Next question 13. Prove that the volume common to the sphere x square plus y square plus z square equal to a square and the cylinder x square plus y square equal to ay is 2 by 9 into bracket 3 pi minus 4 into a cube. This is the sphere. x square plus y square plus z square equal to a square, center at origin and with radius a, and this is the cylinder x square plus y square equal to ay, and this is the cylinder, this portion is cylinder. So common volume this portion sphere and the cylinder, common portion of this, and this is the cylinder, portion, this in the xy plane, this. So so from this sphere z equal to plus minus root over of this, so plus for this portion, z when the positive upper portion, upper half of this xy plane, and lower half is negative. So volume in the first quadrant only, so volume in the first quadrant, so this integration, double integration over e z dx dy, and positive sign is taken for the first quadrant. So where e is the shaded region, this portion shaded in first quadrant. In the first quadrant, bounded by the circle x square plus y square equal to ay, this circle means comma z equal to 0, because this circle lies in the xy plane. So this shaded portion is the, actually this is the xy plane, so this is the e, shaded portion e. With this shaded portion, so center for this circle, this 0 a by 2 center, this point, and radius is a by 2, and changing this circle to polar coordinates, x equal to r cos theta, y equal to sin theta, and Jacobian j equal to r when xy not equal to 0 0, and x square plus y square equal to ay, this equal to 0, so r equal to 0 and r equal to a sin theta. Actually this curve is equal to r equal to a sin theta. When theta equal to 0, this is the initial line, theta equal to 0 and theta equal to pi, this theta equal to pi is the y axis, and this, so theta changes from 0 to pi by 2, and r changes from 0 to a sin theta. So the volume of this z, value of z is this a square minus x square plus y minus y square, so this is equal to a square minus a square in the Jacobian j, modulus of Jacobian j dr d theta, and r from 0 to a sin theta, and theta equal to 0 to pi by 2, and j equal to mod j equal to r, so r equal to 0 to a sin theta and d theta, and put a square minus r square equal to p square. So we get when r equal to 0, p equal to a, and when r equal to a sin theta, p equal to a cos theta. So this p into p dp into d theta. So integrating this theta equal to 0 to pi by 2, p equal to a cos theta to a, because this negative sign, so this minus integration a to b means this b to a, integration b to a. So this p square dp d theta, so p cube by 3, limit from a cos theta to a, so we get a cube minus a cube into cos cube theta d theta, and this taking common a cube by 3, so integration is 1 minus cos cube theta, and this theta integration, theta limit 0 to pi by 2, and for this second integration, this integration 0 to pi by 2 cos cube theta d theta. Now we know integration 0 to pi by 2 sin m theta cos to the power n theta d theta is equal to half of b m plus 1 by 2 n plus 1 by 2 when m greater than minus 1, n greater than minus 1. So we get here m is 0 and n equal to 3, so 3 plus 1 by 2, this is equal to 2, and this half. Now bmn, beta function, this gamma m into gamma n whole divided by gamma m plus n, so this gamma half equal gamma 2, this gamma n plus 1 equal to n into gamma n, so 1 into gamma 1, and this gamma 2 plus what, this 3 by 2, 1 by 2, gamma half cancel, so e cube by this. Hence the required volume, so hence the required volume, this 4 into a cube by this integration into pi minus 4 by 3, and actually this is the only first quadrant, so we get only first quadrant. So first quadrant, front side and back side, and the lower quadrant below the first quadrant, front side and back side. So we get 4 into this, total volume is this, 4 into this. So 4 into this, after simplification we get 2 by 9 into bracket 3 pi minus 4 into a cube. This completes the group C multivariate calculus 2 2022. Thank you for watching this video.